My name is Matt Garman, and I'm the Vice President and General Manager for the EC2 service. I'm going to walk you through the State of the Union for Amazon Compute. We're going to do a little bit of a deep dive into how we think about innovation inside of EC2 and our compute services. So I see you guys have done a great job of being as spread out as possible across this enormous room, so good job on that. I'll try to look at you all. But you guys might have seen this. Andy showed this graph during the keynote on the first day. And this shows the growth in EC2 instance usage over the last couple of years. And as you can see, things are just accelerating as far as instance use goes. That's a 99% year-over-year increase on an already pretty large base. And it's part of what I want to do is talk a little bit today on how we handle that growth, both how do we think about innovation that keeps to fuel that growth, but also from an operational perspective on how do we actually support growing at this kind of pace. So our formula, we have two main things that we think about. The first one is customer obsession. And we really believe that us focusing on our customers is really what drives innovation. And we really want to figure out how we can help you guys as customers do more with less. But we also need to know that if we're going to do that, we have to be world-class operators. And being world-class operators at that kind of scale, and as we think about what that graph looks like at reInvent 2015. And we'll walk through a little bit about how Amazon and we at EC2 think about operating at that kind of scale so that you can support us to trust the businesses that you put on AWS. All right, so how do we evolve the platform? And I want to dig in a little bit about, if you think about EC2, the first thing you think about are instance types. And today we announced a new instance type. This is a list of the new instance types that we've just launched over the last year. This morning we announced the C4 instance, which is our new compute-optimized instance with the very fast processors and really dedicated towards high compute-intensive applications. And we've also launched T2 instances focused on lower-end, very low-cost applications that are somewhat lightly used, but need high performance when you want them. We launched R3 instances, which is our latest generation of memory-optimized instances. You can get an instance as big as 244 gigabytes of memory. It's the cheapest way if you just need an instance that has as much memory as possible. This is the highest performing, lowest cost option for you on the AWS platform. It's very popular with many database workloads and in-memory applications. I2 is our I/O optimized platform. It comes with 6 terabytes of local SSD storage with the largest instance size. It scales down from there. Customers can get as much as 350,000 read IOPS out of a single node instance. And many customers also run relational databases on these instances, as well as several other I/O-intensive applications. And finally, we have things that we've been working on that are more specialized. So the G2 instance, as an example, is our GPU-intensive instance. It comes with an NVIDIA GPU as well as in addition to a normal CPU, and has been very popular with customers doing everything from scientific grid computing to things like graphics and application streaming and gaming is a very popular use case for the G2 instance. Now, really what I want to do, though, is talk about, that's the things that we've launched in the last year, but how do we get to those instances? So back in 2007, I'm going to start and walk you through kind of how we thought about the compute family of instances. So back in 2007, we launched our first compute-optimized instance. It was the C1 instance. Up until that point, we had just had instances. There was just one type. So the C1 was really optimized around compute-heavy workloads. It had a lower ratio of memory to CPU, so it was very kind of just focused on giving customers as much CPU as possible. And customers found these very popular for things like batch processing, web servers, other just compute-bound workloads in general. And so we launched these to customers and kind of saw how they used them, and they were quite popular. But we learned from that. And as we talked to our customers, we said, what is it about our compute instances that you like? And they said, well, I love having as much CPU power as possible. I love high frequencies. And then one of the things we learned, though, is and we kept iterating over time. We'd add new CPUs and things like that. And our customers told us, you know what? As you add new features and as you change this, I want to be able to adopt the new stuff and not be stuck with the old stuff. Because our original plan was to just always offer something called C1 and kind of hide changes under the covers. As you might expect, customers wanted to be able to opt into the newer technologies and faster processors and things like that. So we decided to launch a new instance type and a next generation of compute type. That was the EC2 instance, launched in November 2011, so about 4 years later. Faster processors, more modern processors, but also customers told us that our original instance we didn't quite get right. And in particular, they said, look, we love the CPU power, but we actually need a little bit more memory. But we also want them to be bigger. So with the EC2 instance, we launched a much bigger instance. Had more vCPUs. It had, on a relative ratio, about twice the amount of memory as our C1 instance. And we really optimized the network in this one. We gave customers a full 10 gig network in between nodes so that they could do HPC clustering and other applications like that. Then we learned more. Customers adopted the EC2s. They really loved them. But we got some more feedback from customers. They said, awesome, we love the bigger sizes. You didn't give us the smaller sizes, though. Sometimes I have smaller applications that don't need one big, huge size. Oh, sorry, I forgot to do this. With the new clustering, we actually put the instances and tried to run them in a top 500 run. We actually placed 42nd in the top 500 run in 2011. It was the only Ethernet-based cluster in the top 500. It was something we were really excited about, and it was one of those things that showed. It was the first time that we really showed that you could do HPC in the cloud. So it was really one of those cool enabling things that we did. But then we moved to C3. So we launched C3 right around reInvent last year. And one of the things we did is we said, OK, great, we're going to do a new generation of processor. You get all of the benefits of the faster processors with more cores. But we're also going to improve the networking. Customers told us they loved getting the 10 gigs of networking, but they needed more consistency and better performance from that networking. So we added enhanced networking. What enhanced networking does is it effectively allows you to direct map the driver through SROV drivers and get much better network performance. You get lower latency, you get much better consistency, and we measure packets per second. We've talked to customers, and a lot of customers who pass really small messages back and forth through their instances were saying, I'm never limited by the bandwidth that you're giving me, but I'm limited by the packets per second that I can push through the instance. In the C1 instances, it's somewhere between 100 to 200,000 packets per second where you kind of max out your network connection. With enhanced networking, you can get well over 1 million packets per second. We have enhanced networking available on C3s, C4s, R3s, I2s, and all of our new instance types. I want to show you a graph. We measured what our packets per second performance looks like on a CC2, a C3 8 extra large, and a C3 8 extra large when we have enhanced networking enabled. As you can see, these are all 10 gig connections, but with the enhanced networking work we did, if you're using small messages that you're passing back and forth, you get significantly better performance. And that's part of where we really want to continue to optimize these instances. So we did again. We put the C3s in another top 500 run. And we were very pleased with the performance. We actually got, for about the same size cluster, 2x the performance from the C3s in a top 500 run than we got with the CC2s. And when we launched it last year, C3 has been far and away our fastest growing instance that we've ever launched in EC2, largely due to many of these kind of innovations that were driven by customer requirements. And that's really the thing to emphasize is a lot of the things that we do are not because we think they're cool technologies or they're really interesting. These are driven by real use cases where we talk to you guys, the customers, and we get feedback that says, hey, I love what you've got, but. And that's how we really think about improving the platforms that we offer to you. I have a quote here from Pinterest. Pinterest did a migration from C1 to C3 instances. They said, we use Amazon EC2 to serve hundreds of millions of Pinterest users. Our C1 to C3 migration of over 1,200 app servers took no more than 3 days while reducing the EC2 instance footprint by 75% and adding 30% more compute capacity. Such a project could easily take up to 3 months and some serious project management in a traditional data center environment. So it's a great example of kind of the benefits that some of the customers can get because of some of these innovations. And most of that, some of it was due to the faster processors, but a lot of that was also due to a lot of the work that we did in the networking to really improve the performance of those instances. I want to use another example. This is from HGST HGST, excuse me, is part of the Western Digital company. What Western Digital does is they're doing a lot of their design for disk drives. And when they're designing the disk drives, there's a huge number of permutations of different things that they think about as they're designing the head to the disk drive. In this case, there's 22 independent variables on head design, combined with 3 different types of materials that go to the plates of the disk. And they need to run all of those in combination to figure out which of the designs are going to be optimal for each of the disk drive possible things they're going to run. That leads out to somewhere more than 1 million different combinations. They used to run this in an in-house cluster. Their in-house cluster had several hundred cores, and that used to take them about 30 days to generate all of those different probabilities or possibilities and to run through and see which of those are most optimal for their new designs. They decided, together with one of our partners, Cycle Computing, they wanted to see if they could come run this in AWS and really shrink the time and the cost associated with that. They also decided to run our spot market. Our spot market is a place where you can go and place bids, and you get to run on free capacity that's not available, that's not being used by other customers, and you can often get much, much lower rates and very high scale through the spot market. So Cycle Computing helped HGST do this. They started to spin up the cluster. They did some testing with their scale of their application, and they said, okay, let's go for it. Within 23 minutes, they spun up 50,000 cores. They eventually got up to 70,000 core cluster, completed everything in 8 hours, shut everything down for a total cost of about $5,500. If they would have run, so they were able to do this whole thing in 8 hours, as opposed to what was taking them 30 days in their in-house cluster. If they had decided to do that same scale internally, where they wanted to run it in 8 hours, they estimate this would have taken them cost about $15 million to spin up the in-house cluster. So a pretty cool example of what you can do from a scale and cost perspective on AWS. I want to finally get to where we are with C4. So C4 was the new instance type that was announced today. It's based on 2.9 gigahertz custom Intel processor that we worked closely hand in hand with Intel to customize to the AWS environment to give absolute peak performance. A couple of cool things that we've done that we really got customer feedback on. Many of our customers told us, hey, when I'm operating in a bare metal environment, one of the cool Intel features that I like to take advantage of is turbo. I manage my power states, and I can actually get much higher frequencies than just kind of the base level. But with your instances, I'm unable to do that. Well, with this instance, with the very largest instance size, the C4 8 extra large, you'll actually have full control over the power states of the machine, and you'll be able to burst up to 3.2 gigahertz on all cores for the instances, as well as taking advantage of new technologies as part of the Haswell line, things like AVX2 and other instruction sets. So these instances are going to be available in 5 sizes, from 2 cores all the way up to 36 cores, which is our new largest instance that we've ever offered. Only the largest instance will give you control over those power states. The smaller instance sizes will give you some boost in performance from the new processor technologies and things like that, but you won't have that fine-grained control because that is a kind of have to have control over the full machine in order to affect those settings. C4 also has enhanced networking, so you get all the benefits that we talked about before from enhanced networking. But we've also done some things to optimize EBS performance. In particular, one of the feedbacks that we got from customers was, I love using EBS. I love having a lot of network. Part of the problem is my EBS traffic conflicts with my network traffic, and I have to kind of do either or. I get 10 gigs or 1 gig of traffic, and they conflict. With C4, you have completely dedicated network paths. So you have EBS optimized by default, and you have full connectivity to EBS that doesn't conflict at all with your network traffic. So we really did a lot to really optimize our EBS performance on this particular platform, and there's no additional cost for that as well. These instances are coming soon. They should be available within the next couple of weeks, and we really look forward to hearing your feedback on this platform so that we can use that to continue to innovate and learn in this space. On the other end of things, we said, okay, great. So this is a second example. We said, it's interesting looking at the C family, but we talked to a bunch of customers and looked at their CPU utilization. And this is a graph. This is actual customer usage of kind of taking all customer aggregated usage and looking at the most common applications of what actual CPU utilization looks like. As you can see, some people at this high end are using a ton of CPU and basically are maxing out all the processors. A ton of people are not using their CPUs very effectively. We went and said, OK, let's go look at that big chunk. What kind of applications are running there? And it's a mix of things. It's small to medium-sized databases. It's web servers. It's WordPress. It's application servers. Really, anything that you can think about, people were running in these instances. And we were wondering, why are these things largely idle? We think we can do better. And so what we thought of is we said, OK, this is begging for oversubscription. Well, we talked to customers and said, what do you think about us offering an oversubscribed instance? And these are a couple of customer quotes that we got from people. Things like, wait a second, there's no minimum guaranteed of CPU performance? Or do you mean I could get all of a core or get none of a core? And these are a lot of the kind of concerns that people had. Or would I get variable performance over time if the box became more or less heavily loaded? These are a lot of the concerns that people typically have in an oversubscribed world. So we took that as a challenge, and we said we think we can solve that. Our first pass was the T1 Micro. There was one size. We launched it in September of 2010. Had about 600 megabytes of memory, a very small instance. And the way we designed the T1 Micro was you got a very small, consistent level of CPU. We had a guaranteed level that was really small. But when a request came along, it was really kind of targeted at a web server type application. You would get a big burst of capacity where you could get kind of the full core power. But it was very short bursts, and we really limited because we wanted to make sure that we didn't kind of run into these places where customers would get inconsistent performance, where you'd get kind of CPU soakers, people doing kind of encoding or something like that, and come and soak up all the CPU on the box, and the other people wouldn't have any available when they needed it. So we launched the T2 and allowed for these very short bursts. Customers liked the T2s. We got a lot of feedback, though. And this was the free tier instance, so that was great. Enabled us to offer a really low-cost instance, and a lot of people started out on the T1s. Part of the feedback we got, though, was 600 megabytes is really small. It doesn't even load Windows most of the time. And the short bursts were too short. They'd find, they'd sit idle most of the time. They'd try to run a process. You couldn't even build a kernel oftentimes without kind of running out of your CPU balance, things like that. If you actually were able to load Windows, Patch Tuesday pretty much hosed your instance because that was way too much CPU usage. So we learned from that, and we said, OK, we think we can do better. And just this last year, we launched T2. So we decided, OK, we're going to offer more sizes. We offer T2s in a 1 gigabyte, 2 gigabyte, and 4 gigabyte size, so a micro, small, and a medium. But we also said what we want to do is let people earn CPU credits. So what the T2s do is when your instance is sitting idle, and I should back up there. When we mean idle, it turns out when we looked at CPUs, no one's instances really sit idle for 20 minutes at a time. But if you measure them at the kind of millisecond or microsecond time periods, they'll get a process, and they'll spike up really big. And what it turns out what most applications want is they want the full CPU for a really short amount of time, and then they'll go idle for another couple of milliseconds, and then they'll spike up again and be idle for a couple seconds and spike up again. And that's really what the application patterns typically looked like. So what we decided to do is offer people the opportunity to give credits, earn credits. And a credit is basically when you spike. If you're using the full core, that's when you're using it. When you're idle, you're kind of accruing credits. So we looked at a lot of the usage patterns that we see in the fleet, and we said, we can build an instance where most of the time people get full cores on these T2 instances. If they're running them steady state, we'll give them a relatively low, although slightly higher than before, level of performance. But most applications don't operate that way, and we think that we can actually manage that and give people a really consistent performance all of the time for those kind of applications that occasionally need bursts of CPU. And so we allow T2s to burst up to 3.3 gigahertz. You get full core access. So you basically get a very, very powerful core on your small instance when you need it. And when you're idle, you're earning credits. Credits are earned. T2 Micro can earn up to 6 minutes of credit an hour. And so over a couple hours, you can actually run steady state for several minutes at a time and then go idle. Or you can kind of have a bunch of these little microbursts. So we launched this. They've been incredibly popular with customers. The performance has been really good for the T2s. And we've measured only 2.5% of customers ever bump up against their credit limit. So most applications that are running the T2s think they get all the cores all of the time. and they never know the difference. So then we said, I wonder if we can apply this to EBS. So a couple years ago, we launched provisioned IOPS, where we have very high-performing EBS volumes, where we let people provision exactly how much IOPS they need, and we make sure that we reserve that for customers. Similarly, we said, I bet there's a similar use case where most people need a lot of IOPS, and then they'll be idle for most of the time, and they need a lot of IOPS, and they need to calculate, and then they'll be idle. So we launched general purpose volumes. General purpose volumes are SSD-backed. You have a baseline of 3 IOPS per gigabyte, but you can burst up to 3,000 IOPS in a 30-minute period for up to 30 minutes. Target use cases are, you can imagine things like boot, small to medium-sized databases where you really want a bunch of IOPS for concerted periods of time, but you're kind of lightly used for the rest of the time. We thought this, in combination with T2, would be an awesome oversubscribed offering for customers. And when we look at GP2, which is the general purpose volumes, we see that only 0.3% of volumes actually ever run out of their burst credits. So the vast majority of GP2 volumes are getting up to 3,000 IOPS whenever they want them for the application. A couple of other details on how we've evolved EBS. We've heard from customers, we love some of these things that you've launched, GP2 and PIOPS, they're awesome offerings. But you're making me stripe them together if I need something bigger. Our max size was 1 terabyte, our max IOPS were 3,000, et cetera. Today, we announced that we're offering bigger sizes for those, so you guys don't have to do a lot of that hard work of striping those volumes together. You can get a single volume of either of those up to 16 terabytes and up to either 10 or 20,000 IOPS, depending on the different volume types. So we continue to kind of push that edge of the performance and really through oversubscription, continue to lower the cost of what some of these are going to cost. And here's one quote from our customer, Glimpse. They said, I love the T2 instance. I'm shocked and surprised at how well they perform. We saw 74% cost savings when we moved to them. So some pretty cool numbers. I'm going to hand it over to Tom, who's going to walk through a demo of the T2s and show you live kind of what we can see from these things.
Thanks, Matt. If you'd cut over to the other mic, please. So we're going to do a little demo. I hope everyone's comfortable. We're going to go to the command line, and we're going to use CloudWatch for a second. So I'm going to switch now to my demo machine, then we'll come back to PowerPoint in a second. Okay, there we go. So what we have here, this is an M3. Let's see, make sure we're good there. Oh, broken pipe. Let's come back. Okay, let's go ahead and launch a CPU test on this. This is just a sysbench looking for a few 100,000 primes. This is on M3 medium. We're going to do the same thing on a T2. Okay. And for those of you, we'll take a look at CloudWatch in a second there. Okay, I'm going to switch back to PowerPoint now. Okay. Could you put PowerPoint up on the screen, please? Okay, I'll talk through these while we wait. When you look at the T2 medium, it is, as Matt mentioned, it's an excellent price performance. For a 3-year heavy utilization reserved instance, it's about $17. It's exactly $17.87 a month. And it's great for those bursty workloads. It actually bursts up to the level of a C3 large in terms of performance. Now, a C3 large also has about 4 gigabytes of memory. It's got 3.75. And its price is about $30, $29.95. Another instance that people might use or think about is the M3 medium, which is the one that you saw in the demo here just a second ago. It's priced at $20.16. So they all sound pretty cheap, right? $17.87, $20.16, roughly $30. But actually, there's a fair, substantial difference in price between those. So in the demo, what you're going to see, we're going to come back and we're going to take a look at CloudWatch. How many folks here use CloudWatch regularly to see what their instances are doing? Okay, I see about, what, 20, 25% of the hands up. Folks, if you don't do that regularly to profile your instances, you're actually missing a chance to improve your performance and save money. So hopefully this is something that you will look at doing. And what you're going to see is, I'm just going to go straight back to the demo machine because PowerPoint's not coming up here. What we're going to see is that, come back here. Okay, you can see that the T2 is finished finding those 100,000 primes. So let's go ahead and launch it again. And now let's come over and take a look at CloudWatch. So this is CloudWatch. We're looking at two metrics. We're looking at the CPU utilization, as you can see, for an M3 medium and also for a T2 medium. And this is what I ran just prior to launching that demo. We'll refresh in a second. And you can see the blue line here is the CPU utilization of the M3 medium. The orange line is the utilization of the T2 medium. And you can see that the T2 got the job done much, much quicker. So let's go ahead and refresh this. And, okay, from 30 minutes ago. Oh, let's look at this from 10 minutes ago. Okay, I guess it hasn't picked up the latest data. So let's go back and take a look at what we had this morning. So this morning I ran the same thing. This was in the demo that I gave yesterday. And what you can see is that 11:08 I kicked both jobs off, and the T2 and the M3 both spiked up to 100% utilization. Then the T2 finished its work, and as I like to say it, it had time to have a cup of coffee, then went and did the job again, and maybe had almost another cup of coffee before the M3 caught up. So it's really a fantastic way for you to get work done. It bursts up to the level of the C3 large and saves some money at the same time. So now we're going to switch back to PowerPoint. Okay. Well, let's try it again. Okay, guys in the back, if you could switch, that'd be great. Get PowerPoint on the screen. Okay, I'd like to tell you about one more customer. Matt mentioned one customer already. I'd like to talk to you about what Kaplan found. Kaplan's a customer, and they started not on the T2. They started on with another series of instances. But over time, they looked at the T2, and they found it met their needs. And they actually were very rigorous about measuring it. They used CloudWatch and other tools to say, hey, can the T2 meet our needs? And they found that it could. And they moved a substantial, or in their words, a hefty number of workloads. Thank you. They moved a hefty number of workloads onto the T2. And at this point today, if you're at Kaplan and you want to bring up a new instance, do something new, you start with the T2 until you can show that that's not the case. So their default is the T2. Now, if the T2 works for you, what's the savings potential? Just in EC2 charges alone, and there's more benefits, if you're switching from an M3 medium to a T2 medium, you're going to see 11%. If you're switching from a C3 large, you can see a 40% savings. On top of this are the savings by using the GP2 EBS and other systems, and a possibility of combining loads onto a single system. This is a fantastic way to save money, and I encourage everyone in the room to consider using the T2. With this, Matt, you want to talk about operational excellence at scale?
All right, thank you. So I want to take a couple minutes, and we gives you a little bit of an insight as to how we think about the product development process and how we think about innovating on some of our instances and storage and other offerings like that. We want to talk about how do we operate at that. Now, go back to this graph. It's great that we're being able to drive that kind of adoption. Part of what we have to think about is how do we want to go operate? And it's not enough for us to innovate. We have to make sure that we do an outstanding job operating as we continue to grow this kind of scale and as that graph continues to go up. Now, first of all, and you guys have heard this before, one of the key things is measuring everything. This is a sample of some of the things that we do. Internally, we know, and you guys know, if you're going to operate a service well, you have to measure everything. You have to measure metrics, you have to alarm against metrics, you have to look at metrics. Our services literally have hundreds and hundreds of graphs that they look at. This is just a small sampling of things that we look at on EC2 and ELB. And on a weekly basis, all of our teams, a daily basis, our teams are looking at all of these different metrics and trying to find areas of their service that may not be performing as well as they like. And hopefully finding errors before they impact you. When we do find an error, Amazon has an interesting policy where we decide to be reflective. And our goal is to dive deep into every single error that we find to really understand what is the root cause. One of the key things about how we make sure that we operate excellently is every time we find something that goes wrong, we want to know what that root cause is. Understand the impact, focus on the events, not just the ones that impacted you guys, but there might be impacts that never were customer visible, but we know could have led to a customer visible event had we not captured them, and we really dive into those with the same level of focus to figure out what we can do to make sure those don't happen again. You start with asking why, and then you ask why again, and you ask why again. Kind of the 5 whys, but you don't have to stop at 5. You continue to ask why until you really get to the root of the problem and really understand exactly what went wrong and what mechanisms you can build for systems at scale to make sure that you don't have that problem again. Those are the corrective actions, and our teams many teams across Amazon will regularly kind of reprioritize work to make sure that we focus on corrective actions to make sure that operations continue to go smoothly as things scale. Because if there's one thing you learn at scale is that no matter how unlikely a problem is to happen again, it will happen again at scale if you don't go fix the root problem. So part of what we also want to do is build mechanisms to fix these things. And sometimes when we think about hard problems, they're not just errors, but what we really want to do is figure out what causes any sort of variations inside of performance. So one of the things that customers have told us that used to be a struggle for them is variability in performance. We call that jitter. And that's either it's network performance, it's EBS I/O performance. Variability in performance of your application causes issues and causes you guys problems. So what did we do? We said we need to go figure out how to solve jitter inside of our environment. Well, it's a very ambiguous problem. You've got to go track down network variability. You have to track down I/O variability. What we did, we established a core working group who met every single week to track down sources of jitter. We set SLAs internally for us. We set goals for us. And over the last several years, that team has been meeting every single week, focused on nothing else but making sure that we improve jitter. And when we think about jitter, we're not looking at average performance. We're not looking at the 90th percentile. We're often looking at the 4 nines level of performance. And you can see this is the TP999 level of jitter performance, where we're looking at the far outliers to make sure that we understand why we're seeing any variabilities in performance. When we find things that we don't like, we set goals on how to improve them, and we have very clear owners that are going to go drive those and solve the problems to improve performance for customers. Here's another great example from EBS Provisioned IOPS. We launched several years ago, and we launched with an external SLA where we would provide up to 90% of the provisioned IOPS for a customer volume at all times, 99% of the time. Well, internally, we measure ourselves to a much higher level than that. We measure the 99th percentile 99% of the time. And you can see, when we started out, we set goals where we wanted to be above 99%. Our external SLA was 90. We wanted to be above 99 internally. And as you can see, when we started out, we were at 92. And we continued to iterate over time. And over time, we got better and better and better. And now we are still working on this. Even though we're well above our internal goal, we still are working on how to make variability in our performance much better. You might have seen this graph this morning. This is the result of our jitter performance on network variability. When we have enhanced networking, you can see that as we're measuring your average network performance, your P90 and your P999, we see very low variability with regards to latency when we test many samples of network latency inside of the network. And again, we're continuing to work to improve these variabilities as well. And the most important thing as we think about operations and as we think about features is it's really still day one. And this is a quote from Jeff. There's so much stuff that is yet to be invented. There's so much new that's going to happen. People don't have any idea yet how impactful the internet is going to be, and this is still day one in such a big way. That was Jeff's quote from many years ago, but it's still applicable to everything that we're building. From AWS and from a compute environment perspective, it really is still very early. We love getting feedback from you guys on how you're using our services. We love getting feedback from you guys on things that we can do better. And we use a lot of that to fully feed back into our product development process and in our operations process to improve the services that we offer. So that's it. We have a couple of minutes left. I'm happy to take any questions that you guys have. No? If not, that's it.